Hello there, and welcome to Midnight Geography. Tonight we'll drift into the gentle embrace of Aotearoa, the land of the long white cloud. New Zealand is more than distant islands at the world's edge. It's a fragment of ancient Gondwana that chose solitude, carrying stories written in volcanic stone and glacial ice. Here, tectonic plates meet in perpetual slow dance, folding Earth into forms that exist nowhere else. If you enjoy these peaceful geographical explorations, consider liking and subscribing. It helps other curious minds find their way here too. But for now, let's begin. The Marlborough Sounds hold a secret that only becomes clear from above. What appears to be a coastline stretches for 1,500 kilometers. Yet all of this intricate edge exists within a region merely 50 kilometers wide. These are drowned valleys, ancient rivers that once carved their way through hills when the sea level sat far below today's mark. After the last ice age loosened its grip, the waters rose slowly, century by century, filling these valleys with the Pacific's embrace. The mountains became islands, the ridges became peninsulas, and what was once a landscape of flowing rivers transformed into a labyrinth of waterways. Ships navigate where deer once walked. Fish swim through spaces that knew only birdsong. The transformation was so complete that calculating the actual coastline becomes almost impossible. Each inlet branches into smaller coves, each cove into tiny beaches, creating a fractal edge between land and sea that seems to multiply the closer you look. Not far from these peaceful sounds lies Lake Taupo, its surface reflecting clouds in perfect serenity. Yet beneath this calm water rests the scar of one of Earth's most violent moments. 26,500 years ago, this place knew no lake, only solid ground that suddenly wasn't. The eruption that created this caldera ejected over 1,000 cubic kilometers of material, enough to bury entire countries. The explosion would have been heard across half the planet, and its ash fell as far away as Antarctica. Today, trout swim where magma once churned. Vacation homes dot the shores of what is essentially a flooded volcanic wound. The lake itself serves as a giant mirror, 40 kilometers long, hiding its violent birth beneath waters so peaceful that sailors often comment on its unusual stillness. The volcano sleeps now, but the hot springs around its edges whisper reminders that deep below, the Earth remembers its fury. On the South Island's western coast, two rivers of ice perform an unusual descent. The Fox and Franz Josef glaciers flow down from the southern Alps, reaching just 300 meters above sea level. An impossibility, it would seem, for glaciers at this latitude. Nowhere else at 43 degrees south does ice creep so close to the ocean. The secret lies in the mountains' geometry and the weather patterns they create. Moisture-laden winds from the Tasman Sea strike these peaks and rise sharply, dropping extraordinary amounts of snow in the high valleys. This constant feeding allows these glaciers to push down through temperate rainforest, where ice and tree ferns exist in the same view, a combination that shouldn't exist, yet does. The glaciers advance and retreat in cycles measured in decades rather than centuries, responding to subtle changes in snowfall and temperature with surprising speed. During certain years, they surge forward at rates that can be measured weekly, the ice creaking and groaning as it bulldozes through valleys lined with prehistoric podocarp trees. Beneath the Canterbury Plains, hidden from all eyes, lies an aquifer system of extraordinary purity. 70 cubic kilometers of water rest in darkness, filtered through gravel beds laid down over thousands of years by braided rivers flowing from the southern Alps. This underground reservoir holds more fresh water than all of New Zealand's lakes combined, yet it remains invisible, known only through bore holes and springs. The water moves slowly through layers of river stones, each meter of travel removing more impurities, until what emerges is so clean, it needs no treatment. Some of this water fell as rain centuries ago, beginning its journey in mountain storms and ending in kitchen taps. The aquifer breathes with the seasons, swelling with winter snow melt, contracting during dry summers, maintaining a hidden rhythm beneath farms and cities. Engineers speak of it with reverence, this buried treasure more valuable than any gold, flowing in absolute darkness through spaces no human has seen. Along the Kukohe beach, perfect spheres of stone emerge from eroding mudstone cliffs like ancient eggs laid by geological forces. The Moiraki boulders, some reaching 3 meters across, formed 60 million years ago on the seafloor through a process called concretion. Minerals in the sediment crystallized outward from central points, growing sphere by sphere like pearls in slow motion. What took millions of years to form now takes only decades to erode once exposed to air and waves. Each boulder contains patterns like septarian nodules, cracks filled with yellow calcite that create designs resembling turtle shells or dragon scales. Maori legend speaks of these as gourds and fishing nets from the great voyaging canoe Aotearoa, washed ashore after a wreck. Scientists speak of carbonate precipitation and bacterial decomposition. Both explanations seem equally mysterious when you stand before these perfect forms, wondering how nature creates such geometry without compass or calculation. Stewart Island exists in perpetual baptism, receiving rain on 265 days each year. This constant moisture creates temperate rainforests, where tree ferns unfurl beneath southern beaches, where moss grows on moss in layers thick enough to hide your hand. The entire island seems to exhale water vapor, creating its own microclimate of mist and shadow. Birds here sing different songs than their mainland cousins, evolved in isolation to fill niches that don't exist elsewhere. The rain falls so frequently that locals stop noticing it, working and walking through drizzle as if sunshine were the aberration. This water shapes everything. The curved leaves that channel rain to roots, the spongy forest floor that never quite dries, the streams that appear and disappear with each storm. Even the island's Maori name, Rakura, means glowing skies, a reference to the aurora australis that dances here, or perhaps to the long twilights that paint wet forests gold. In Auckland's Waitemata Harbor, Rangitoto Island rises as the youngest volcano in a field of 53 volcanic cones. Just 600 years ago, this island didn't exist. Then, witnessed by Maori inhabitants who watched in awe, the sea began to boil. Lava fountained from the seafloor, building an island in real time. The people named it Bloody Sky for the red glow that painted clouds for months. Today, pohutukawa trees grip black basalt with roots that crack stone, and the world's largest pohutukawa forest grows on rock barely older than some European cathedrals. The volcano built itself symmetrically, a perfect shield rising 260 meters, visible from every beach and headland in Auckland. Its black stones still look fresh, as if the eruption ended yesterday rather than centuries ago. Walking its slopes, you step on rock younger than many buildings, crossing lava flows that cooled when Shakespeare was learning to read. Beneath the rolling farmland of Waitomo, another world exists in darkness. 45 kilometers of surveyed passages wind through limestone, with divers still discovering new branches in flooded tunnels. These caves breathe. Air pressure changes cause winds to blow in and out of entrances, making the underground feel alive. Water drips constantly, each drop carrying dissolved limestone that builds stalactites and flowstone formations. In some chambers, glowworms create false skies, their blue-green light reflecting in still pools until you can't tell ceiling from floor. The limestone itself, formed from countless shells and skeletons, compressed on an ancient seafloor, then lifted above sea level and hollowed by millions of years of rainfall. Rivers disappear into holes and emerge kilometers away, running through spaces that range from cathedral vast to barely human-sized. The cave system continues to grow, water finding new weakness in rock, dissolving grain by grain passages that won't be discovered for centuries. At the bottom of the South Island, Slope Point endures winds so relentless that trees cannot stand straight. They grow bent at right angles, all leaning the same direction like nature's weather vanes frozen in wood. The wind here averages 60 kilometers per hour, with gusts that can knock adults off their feet. These trees, macrocarpa and pine mostly, don't choose this shape. The wind sculpts them from saplings, training each branch to surrender to the inevitable. Their trunks thicken on the windward side, developing compression wood that's denser and stronger. Some trees have grown for decades in this permanent bow, their crowns brushing the ground they'll never stand tall above. Sheep shelter in their lee, and the bent trunks create tunnels where lambs play on rare, calm days. The wind carries salt from the Southern Ocean, pruning any growth that dares reach skyward, creating a landscape that looks like time itself has been blown sideways. The Waimangu Volcanic Valley exists as Earth's youngest geothermal system, every feature less than 140 years old. Before 1886, this was forested land with a river running through it. Then Mount Tarawera exploded, reshaping everything in hours. The valley cracked open, and superheated water found new paths to the surface. Frying Pan Lake, the world's largest hot spring, formed in one of these craters, its water maintaining a constant simmer across a surface larger than several city blocks. Echo Crater holds water so acidic it can dissolve metal, colored emerald green by dissolved minerals. Steam rises everywhere, and the ground itself feels warm underfoot. Plants here must be specialists, species that can tolerate soil temperatures that would cook normal roots. This landscape changes yearly as new vents open and old ones seal, as lakes appear and disappear, as the earth continues settling from that night of violence. Scientists study it like a newborn, watching geological processes that usually take millennia happening in human timescales. 90 Mile Beach stretches along the western coast, though it measures only 55 miles in truth. This naming error persists, embedded now in maps and mines. The beach serves as an official highway, the sand packed so firm that vehicles travel at highway speeds between dunes and waves. At low tide, the beach widens to nearly 200 meters, creating a temporary boulevard of sand. Aotearoa shellfish once lived here in millions, filtering the surf zone, but over-harvesting reduced them to scattered populations. The sand itself tells stories. Black magnetite grains from volcanic erosion, white quartz from granite mountains, tiny garnets that gleam red in certain lights. Wind shapes this beach more than waves, building dunes that march inland unless anchored by vegetation. Sometimes, storms expose ancient kauri forests buried in the sand, trees that grew here 30,000 years ago when the sea level was lower and this beach was far inland. At Punakaiki, the pancake rocks demonstrate nature's ability to create architecture without architects. These limestone formations stack in perfect layers, each band representing a period of deposition on an ancient seafloor 30 million years ago. Between harder limestone layers, softer mudstone eroded faster, creating the illusion of stacked pancakes or books on a shelf. The sea carved blowholes through weaknesses in the rock, and during high tides with heavy swells, water explodes skyward through these vents with sounds like thunder. The rocks continue eroding, about 1 millimeter per year, slowly reshaping into forms that will look entirely different in another million years. Walking among them feels like exploring ruins of a civilization that never existed, all right angles and parallel lines that seem too ordered for nature. Yet every line formed through patient accumulation, particle by particle, over time spans that make human history seem like a single breath. Castle Hill's limestone boulders rest in tussock grasslands like a giant's abandoned game of marbles. These rocks formed when this area lay beneath a warm sea 35 million years ago, accumulating from countless shells and marine organisms. Now they stand 700 meters above sea level, weathered into fantastic shapes, some balanced impossibly on thin bases, others hollowed into shelters. The limestone weathers differently than surrounding rocks, creating an island of gray stones and golden grass. Each boulder has its own character, worn by rain and frost into forms that suggest animals, faces, or abstract sculptures. Rock climbers know individual stones by name, having memorized every hold and feature. In certain lights, the limestone glows almost white, while shadows turn deep blue in the hollows. Maori knew this place as a spiritual site, and even today, visitors speak of its unusual atmosphere, as if the stones hold memories of their underwater birth. The Otago Peninsula hosts the world's only mainland breeding colony of royal albatrosses, birds that seem too large for land. With wingspans reaching 3 meters, they embody flight perfected, able to lock their wings and soar for hours without a single flap. They arrive at Aotearoa Head after years at sea, some having circled the Southern Ocean multiple times without touching land. The colony exists here due to consistent wind patterns created by the peninsula's shape and position. These winds allow the massive birds to take off and land on slopes that face the prevailing weather. Watching them return from sea, they appear first as specks that don't move like other birds, too steady, too effortless. They can live over 60 years, returning to the same nesting site, often with the same partner year after year. Their presence here, at the edge of a small city, seems impossible. Birds that belong to the wildest oceans, nesting where people walk, dogs, and children play. In Lake Wanaka, a single willow tree grows in the water 70 meters from shore. This tree, probably seeded by accident decades ago, has become the most photographed tree in New Zealand. It stands in about 2 meters of water, its roots somehow finding purchase in the lakebed, drawing nutrients from sediment and water. Through seasons, it transforms, bare branches in winter, creating stark geometry against mountain backdrops, full green crown in summer reflecting in still water. The tree floods partially each spring when snowmelt raises the lake level, yet continues growing, adapted to its aquatic life. Photographers wait for perfect conditions, mist on the water, first light painting the mountains pink, or storms approaching across the lake. The tree has become more than vegetation. It's become a symbol of persistence, of beauty in isolation, of nature's ability to thrive in unexpected places. Sutherland Falls drops from Lake Quill in 3 magnificent leaps, totaling 580 meters of vertical fall. The lake that feeds it never runs dry, supplied by Fiordland's 7 meters of annual rainfall. The waterfall creates its own weather system. The falling water pulls air down with it, creating winds at the base that blow constantly outward. In winter, the falls partially freeze, creating ice formations that blue in color and deadly in beauty. The sound carries for kilometers through the valley, a constant thunder that becomes the backdrop to everything. Spray from the falls nurtures a unique ecosystem of mosses and ferns that grow nowhere else in the area, dependent on this constant misting. Early explorers thought it was the tallest waterfall in the world, and while that proved incorrect, it remains one of the most powerful. The volume of water, creating impacts that register on seismometers. In Dunedin, Baldwin Street climbs at a gradient that challenges both vehicles and pedestrians. Officially, the world's steepest residential street, its concrete surface was poured rather than paved with asphalt, which would flow downhill on hot days. Houses here sit at angles that make furniture placement challenging. Everything wants to slide toward the lower walls. Residents adapt to life on a slope, developing unusual calf muscles and learning exactly how hard to pull their handbrakes. During rare snow events, the street becomes impassable, and children use it as a sledding run. The street exists because of Dunedin's grid system, planned in London by people who never saw the landscape they were mapping. They drew straight lines on paper, and builders followed them regardless of topography, creating this monument to determined city planning. Every year, thousands of tourists climb it, arriving breathless at the top to look back down at an angle that seems to defy urban logic. Northeast of New Zealand, the Kermadec Trench plunges into darkness deeper than Mount Everest rises into light. This chasm marks where the Pacific Plate slides beneath the Indo-Australian Plate, disappearing into the Earth's mantle at about 8 centimeters per year. The pressure at its deepest point could crush a human body in microseconds, yet life thrives there. Bizarre fish with transparent heads, amphipods the size of dinner plates, bacteria that feed on chemicals rather than sunlight. The trench generates earthquakes as the descending plate sticks and slips, some powerful, enough to trigger tsunamis. It's a reminder that New Zealand sits on one of Earth's most geologically active boundaries, where ocean floor becomes mountain range, where solid rock behaves like putty over geological time. Scientists have explored less of this trench than the surface of Mars, each dive revealing new species and new questions about life's limits. White Island rises from the Bay of Plenty as New Zealand's most active cone volcano, a place where Earth's interior meets the sea. The island continuously vents sulfur dioxide in plumes visible from space, maintaining an environment so acidic that rainfall has a pH similar to battery acid. The crater floor changes constantly. Lakes appear and disappear, mud pools migrate, and new vents open while others seal. Mining operations once extracted sulfur here, and rusted machinery still stands as monuments to human ambition in impossible places. The island creates its own microclimate, the volcanic gases mixing with sea air to form clouds that hover regardless of surrounding weather. Despite the harsh conditions, seabirds nest on its flanks, and unique bacteria thrive in hot pools, adapted to temperatures and chemistry that would kill most life. Walking on White Island feels like visiting another planet, where the ground steams, rocks are painted yellow and orange with sulfur, and the earth reminds you it's alive, breathing, and entirely indifferent to human presence. Hot Water Beach on the Coromandel Peninsula offers a peculiar ritual that depends entirely on the tide tables. Twice each day, as the ocean retreats, visitors arrive with shovels to dig their own hot pools in the sand. 2 fissures in the bedrock below channel water, heated to 64 degrees Celsius, up through the beach sediments. The hot water emerges only in a small area, perhaps the size of a tennis court, and only accessible for 2 hours either side of low tide. People dig hollows and watch them fill with water hot enough to cook eggs, then temper it with cold seawater until the temperature becomes bearable. These temporary pools last only until the next tide erases them, leaving no trace of the hundreds of small volcanic spas that existed for an hour or two. The phenomenon exists because this beach sits above ancient volcanic activity, where residual heat still warms underground water that follows fractures to the surface. Some days, the sand itself becomes too hot to walk on barefoot, and steam rises from the beach, like morning mist in reverse, ascending rather than settling. Mount Cook, Aoraki and Maori, no longer stands as tall as it once did. Since 1991, New Zealand's highest peak has lost 150 meters of height, not through erosion, but through catastrophic collapse. The mountain sheds itself in violent moments, millions of tons of rock and ice breaking away in seconds, thundering down valleys in clouds of dust visible from 50 kilometers away. These rock avalanches travel at speeds approaching 200 kilometers per hour, riding on cushions of compressed air. The mountain continues to shrink even as tectonic forces push it upward 7 millimeters each year. This paradox defines the Southern Alps. They rise and fall simultaneously, growing through compression while erosion and gravity tear them down. Climbers who summited decades ago reached a peak that no longer exists, their photographs showing a mountain profile that has vanished into rubble spread across glacial valleys. The summit rocks now lie in the valley floors, slowly being ground to sand by glaciers that carry the mountain to the sea, grain by grain. At Waiotapu, the Champagne Pool maintains a constant simmer, its surface at 75 degrees Celsius, decorated with orange antimony deposits that form a brilliant rim around waters colored like oxidized copper. This hot spring spans 65 meters across, making it one of the largest in New Zealand. The water contains dissolved gold and silver, along with mercury and arsenic, a toxic cocktail that supports only the most specialized microorganisms. Carbon dioxide bubbles constantly from the depths, creating the champagne effect that gives the pool its name. The pool formed 900 years ago in a hydrothermal eruption, and its overflow has built terraces of colorful silica deposits that step down toward a cooler stream. These minerals precipitate as the water cools, creating formations that grow about 1 millimeter per year. The colors tell chemical stories: orange from antimony, green from ferrous compounds, white from silica, yellow from sulfur. Steam drifts across the surface, and on cold mornings, the entire pool disappears in fog, revealing itself slowly as the day warms. Farewell. Spit extends into the Tasman Sea like a giant fishhook, 26 kilometers of sand held in place by nothing more than marram grass and the balance of currents. This sand comes from the Southern Alps, eroded and carried north by rivers, then swept along the coast by currents until the change in coastline direction causes it to drop from suspension. Over 6,500 years, 550 million cubic meters of sand have accumulated here. The spit continues to grow, adding about 3 meters to its length each year. Wind shapes the sand into dunes that migrate across the spit, some reaching 30 meters in height. During storms, waves wash completely over narrow sections, temporarily turning the spit into islands. The curved inner edge creates a vast intertidal zone where millions of migrating birds stop to feed, probing the mudflats for invertebrates. The spit acts like a natural trap for whales, its shallow waters and confusing shape causing regular strandings. From above, it looks like the land reaching for something it can never quite grasp, a finger of sand pointing toward Tasmania. The pink and white terraces once cascaded down hillsides near Lake Rotomahana, silica formations built by thousands of years of hot springs depositing minerals in delicate layers. Visitors in the 1800s called them the eighth wonder of the world. traveling from Europe just to bathe in the warm pools that formed natural infinity pools overlooking the lake. The pink terraces covered 3 hectares, colored by trace amounts of iron oxide, while the white terraces spread over 8 hectares of pure white silica. Then, on June 10, 1886, Mount Tarawera exploded, and within hours, both terraces lay buried under 60 meters of volcanic debris. The lake itself transformed, rising 40 meters as debris dammed its outlet. For over a century, the terraces existed only in paintings and memories, until recent underwater surveys suggested parts might survive beneath the new lake level. These ghostly remnants lie in darkness now, possibly intact but forever inaccessible, preserved in a tomb of water and mud. Their destruction reminds us how quickly Earth can erase what took millennia to build. Lake Matheson near Fox Glacier creates reflections so perfect that photographers struggle to tell which half of their image shows sky and which shows water. The lake owes its mirror quality to dissolved organic matter leached from the forest floor, staining the water dark brown like tea. This dark water absorbs light rather than scattering it, eliminating the sparkle that disturbs most water surfaces. On still mornings before wind disturbs the surface, Mount Cook and Mount Tasman appear to extend downward into the earth as perfectly as they rise above it. The lake formed 14,000 years ago when the Fox Glacier retreated, leaving a depression that filled with rainwater. Ancient kahikatea trees line its shores, their own reflections creating corridors that seem to extend infinitely downward. The brown water that creates these reflections also makes the lake appear bottomless, though it reaches only 6 meters deep. Early Maori used the lake as a food source, catching eels that grew fat in its organic-rich waters. The Hauraki Gulf embraces 50 islands scattered across 4,000 square kilometers, each maintaining its own microclimate shaped by surrounding currents and winds. Some islands harbor forests that disappeared from the mainland decades ago, preserved by water barriers that pest species couldn't cross. Others remain barren, stripped by introduced animals until only grass and rock remain. The Gulf's waters mix warm East Auckland current with cooler upwellings, creating conditions where tropical fish swim alongside temperate species. Channels between islands accelerate tidal flows, creating races where water moves like rivers within the sea. Great Barrier Island sits far enough out to catch weather systems that miss the mainland entirely, receiving storms or sunshine independent of Auckland's weather just 60 kilometers away. Rangitoto's black basalt absorbs heat differently than Waiheki's sedimentary rocks, creating thermal patterns that affect cloud formation. Each island tells a different story, some volcanic, some uplifted seafloor, some built from accumulated shells and sand. Curio Bay preserves a forest that grew when dinosaurs walked the earth 180 million years ago. At low tide, petrified tree stumps emerge from the surf, still standing where they grew during the Jurassic period. These trees, ancient conifers and tree ferns, were buried by volcanic ash and floods. Their wood replaced molecule by molecule with silica until they became stone. The fossilized logs lie exactly as they fell, some reaching 30 meters in length, their growth rings still visible, their bark patterns preserved in rock. You can walk among these stone trees for only a few hours each day before the tide covers them again. The forest extends underwater and underground, with more fossilized trees buried in the cliff faces, slowly being exposed as the sea erodes the softer surrounding rock. Walking here feels like time travel, stepping into a world before flowers evolved, when forests looked alien to modern eyes, when the land that would become New Zealand was still attached to Gondwana. The Raukamara Range on the East Cape rises faster than any other New Zealand mountains, lifting 10 millimeters every year as the Pacific Plate slides beneath the Australian Plate. This rapid uplift exposes rocks in the river valleys that were deep underground just thousands of years ago. The mountains rise so quickly that rivers cutting through them create gorges with nearly vertical walls, racing to keep pace with the rising land. Earthquakes accompany this growth, sometimes lifting entire sections several meters in seconds. Trees on these mountains show the stress of constant movement, their trunks curved and twisted as the ground shifts beneath them. Ancient marine fossils appear near peaks, lifted from seafloor to mountaintop in just a few million years. The range catches moisture from the Pacific, creating isolated pockets of cloud forest where mosses grow thicker than mattresses. This geological youth makes the mountains unstable, prone to massive landslides that can reshape entire valleys in moments. Milford Sound receives rain on more than 200 days each year, accumulating up to 9 meters of precipitation that creates a unique two-layer marine system. Fresh water from this rainfall forms a dark layer floating above the denser seawater, sometimes 10 meters thick. This dark freshwater layer blocks sunlight, allowing deep water species like black coral to grow at depths where they'd normally need to be hundreds of meters down. After heavy rain, hundreds of temporary waterfalls appear, cascading directly from hanging valleys into the fjord. These waterfalls can disappear within hours once rain stops, leaving only wet streaks on cliff faces. The sheer volume of fresh water changes the fjord's ecology, creating conditions where marine life must adapt to varying salinity. Sterling Falls and Lady Bowen Falls flow permanently, but after storms, the fjord walls become curtains of falling water. The sound during these times becomes overwhelming. Not just the waterfalls, but the echo they create in the enclosed space, a roar that makes conversation impossible. The Honua Ranges quietly perform the essential task of providing Auckland with water, their forested hills collecting rain that fills 4 storage dams. These ranges receive over 2 meters of rain annually, filtered through native forest before flowing into reservoirs. The forest acts as a living filter, tree roots stabilizing soil, preventing erosion that would muddy the water supply. Kauri trees once dominated these hills, but logging removed most giants, leaving only scattered groves. The ranges create their own weather, forcing moist air upward where it cools and drops rain, even when Auckland remains dry. Walking tracks follow old tramways that once carried kauri logs, now overgrown with ferns and nikau palms. The dams themselves changed the landscape, flooding valleys where villages once stood, their remains now deep underwater. The ranges harbor species extinct elsewhere in Auckland, protected by the buffer zone around the water catchment. At night, moorporks call across valleys that echo in the still air, and glowworms light creek banks where the water begins its journey to the city. Cathedral Cove exists as a masterpiece of erosion, where 16 million years of wave action carved a passage through volcanic rock. The archway stands high enough that people look tiny walking through it, and wide enough that light floods through even at sunset. The rock here is ignimbrite, formed from compressed volcanic ash that erupted from what is now the Coromandel Peninsula. Waves found a weakness where 2 types of rock met, gradually widening a crack into a cave, then breaking through to create the arch. At high tide, waves surge through the passage, but at low tide, you can walk on sand from one perfect beach to another. The arch continues to evolve. Small rockfalls happen regularly, and eventually the roof will collapse, leaving sea stacks like those already standing offshore. The acoustics inside focus sound so that whispers carry from one end to the other, and wave sounds amplify into rhythmic booms. Plants grow in impossible places on the arch ceiling, their roots following invisible moisture through solid rock. Lake Manapuri plunges to depths of 444 meters, making it deeper than most of the ocean surrounding New Zealand. This depth creates water so pure it needs no treatment for drinking, filtered through centuries of circulation in a basin carved by glaciers. The lake holds mysteries in its depths, underwater valleys and ridges mapped by sonar but never seen by human eyes. Its water remains at 4 degrees Celsius below 60 meters, regardless of season, creating a stable environment where ancient species might survive unchanged. The lake's depth affects its behavior. It never freezes despite cold winters, the deep water moderating temperature extremes. Winds create internal waves called seaches, where the entire lake tilts back and forth like water in a bathtub, though the movement is imperceptible except to sensitive instruments. The deepest point could swallow Auckland's Sky Tower with room to spare above, yet from the surface, the lake appears serene, giving no hint of the abyss below. The Tonga-Perudu coastline once displayed 3 sea stacks called the Three Sisters, elegant pillars of layered rock standing in the surf. These formations lasted thousands of years, surviving countless storms, until 2003, when one sister collapsed without warning on a calm day. The remaining 2 continue their slow dissolution, grain by grain, wave by wave. These stacks formed from alternating layers of mudstone and sandstone, each responding differently to erosion, creating the distinctive banded appearance. At low tide, you can walk to their bases and see iron deposits that color some layers orange, while others remain gray or white. The fallen sister left a rubble field that shows how these monuments eventually return to sand and mud. The 2 survivors lean slightly, suggesting their time is limited. Photographs from different decades show subtle changes, a narrowing here, an overhang there. Local residents check after each major storm, knowing that one day they'll arrive to find only one sister, then none. The coast returned to an uninterrupted line. Arthur's Pass demonstrates how mountains create their own weather patterns in the most dramatic way. The western side receives 5 meters of annual rainfall, while the eastern side, just 5 kilometers away, receives only 1.5 meters. The southern Alps force moisture-laden winds from the Tasman Sea upward, causing them to drop their water as rain on the western slopes. By the time the air crosses the divide, it has lost most moisture, descending the eastern side as a dry wind that sometimes raises temperatures by 10 degrees in minutes. This creates 2 different worlds within walking distance: temperate rainforest on one side, dry beach forest on the other. Plants that thrive on the western slopes cannot survive the eastern drought, creating a sharp botanical boundary at the pass. The difference appears in the rivers too. Western streams run full year-round, while eastern ones shrink to trickles in summer. Clouds often sit exactly at pass level, so travelers drive from rain into sunshine in seconds, emerging from gray curtains into blue sky like passing through a portal. The Aotearoa Basin holds New Zealand's largest cave entrance, an arch spanning 43 meters wide and 37 meters high, large enough to fly a small plane through. This limestone gateway formed over millions of years as the Aotearoa River carved through rock, eventually abandoning this route for a lower passage, leaving the arch dry. Ferns grow from the arch ceiling, their roots following cracks in the limestone to find moisture. The acoustics create an amphitheater effect where every sound amplifies and echoes. Morning mist often fills the arch, creating a white wall that obscures the forest beyond until sunlight burns through. The limestone continues inside as a cave system extending kilometers into the mountain, with passages large enough to build houses in. The river that carved this arch still flows nearby, working on future arches that won't be complete for thousands of years. Standing beneath this span of rock, you grasp the patience of geological time, how water and centuries can move mountains. Lake Ratomahana transformed completely in a single night during the 1886 eruption, rising 40 meters when debris blocked its outlet. The original lake was warm, heated by hot springs, including the famous pink and white terraces. The new lake is cold and deep. Its pre-eruption features drowned beneath waters that shouldn't exist. Sometimes gas bubbles rise from the old hot spring vents, breaking the surface in rings that expand and disappear. The lake edges show the old shoreline clearly, a bathtub ring on the landscape marking where water found its new level. Trees that once grew on dry land now stand dead in the shallows, their bleached trunks marking the boundary between old and new worlds. Underwater surveys reveal the ghost landscape below, the course of the old river, the sites of villages, possibly fragments of the terraces themselves. The lake continues to evolve, with new hot springs developing along its edges, suggesting that one day it might warm again, returning to something like its former state. The Crown Range Road climbs to 1,076 meters, making it New Zealand's highest sealed road, linking Queenstown and Wanaka through a landscape that changes dramatically with elevation. The road follows an old gold miner's track, upgraded but still treacherous in winter, when ice and snow make every corner dangerous. At its highest point, you're above the tree line, surrounded by tussock grasslands that turn gold in autumn. The views extend to distant peaks still holding snow in summer, while far below, the valleys show as dark grooves where rivers carved through schist. Weather at the top bears no relation to conditions in the valleys. You can leave Queenstown in sunshine and meet a blizzard at the summit. The road crosses multiple climate zones in 30 kilometers, from wine-growing warmth to alpine conditions where only the hardiest plants survive. In winter, chains become essential, and even in summer, wind can rock vehicles. The descent reveals Lake Hayes far below, appearing suddenly around a corner like a blue eye opening in the landscape. The Waikato River, New Zealand's longest at 425 kilometers, defies expectation by flowing north when most rivers flow east or west to the nearest coast. This northward journey follows an ancient fault line, the river finding, the path of least resistance through landscapes that have shifted and tilted over millions of years. The river begins as a small stream flowing from Lake Taupo, gathering tributaries as it winds through farmland and forest. It powers 8 hydroelectric dams, each creating a lake where rapids once ran. The river's path tells the story of volcanic eruptions that blocked its original course, forcing it to find new ways to the sea. In some reaches, it flows through gorges carved through solid ignimbrite, the compressed ash from eruptions that covered the land 30,000 years ago. Despite its length, the river maintains surprising consistency in flow, regulated by Lake Taupo, which acts as a vast buffer, storing floodwaters and releasing them slowly during droughts. The river ends at Port Waikato, where its fresh water meets the Tasman Sea, creating a mixing zone where salt and fresh water species overlap. Mount Taranaki stands in perfect isolation on the North Island's west coast, a volcanic cone so symmetrical it seems drawn by compass. This solitary mountain creates its own weather system, often wrapped in clouds while sunshine bathes the farmland just 10 kilometers away. The mountain's isolation results from its unique position. Far from other peaks, it forces moisture-laden winds upward alone, creating rainfall patterns that change completely within a few kilometers. On its slopes, you can experience 4 seasons in a single day's climb, moving from temperate forest through subalpine shrublands to snow and ice at the summit. The mountain appears to follow the sun throughout the day, its eastern face glowing at dawn, its western slopes catching the last light. Local farmers know that when Taranaki wears a cap of clouds, rain will follow within hours. The cone shape creates radial patterns in everything. Rivers flow outward like wheel spokes. Forest zones form concentric circles. Even the farmland below follows the mountain's circular influence, creating a perfect geometric pattern visible from space. The Rakaya River has carved a gorge through rock layers that read like a geological textbook, each band in the 50-meter walls recording different chapters of Earth's history. The river cuts through uplifted seafloor, exposing 100 million years of deposition in cross-section. Some layers contain fossils of shellfish that lived in warm seas. Others show volcanic ash from eruptions that darkened ancient skies. The gorge walls reveal how this land has tilted and folded, with layers that once lay horizontal now standing nearly vertical. The river itself runs turquoise with glacial flour, carrying the southern Alps grain by grain to the Pacific. During floods, the water level can rise 15 meters in hours, transforming the gorge into a thundering torrent that moves boulders like marbles. Ancient Maori traveled through this gorge to reach greenstone sources, leaving drawings on sheltered rock faces that still remain. The gorge continues to deepen by about 2 millimeters per year, the river patient in its work of cutting through mountains. Aotearoa chalked Mount Cook National Park contains more glacial ice than anywhere else in New Zealand, with 72 named glaciers covering 40% of its area. These rivers of ice flow down valleys, carrying millions of tons of rock and snow in slow-motion avalanches. The glaciers grind bedrock into flour-fine particles that turn rivers milky blue, a color so distinctive it has its own name: glacial turquoise. Some glaciers here move at different speeds in their centers than at their edges, creating crevasse patterns like frozen lightning. Ice caves form where meltwater carves tunnels through glacier bases, creating blue chambers that glow with filtered sunlight. The park's glaciers respond to climate changes with a delay of decades. The ice melting today fell as snow when your grandparents were children. Each glacier has its own personality. The Hooker Glacier retreats steadily, leaving a growing lake, while the Murchison Glacier spreads wide and thin like spilled honey. At night, the ice creaks and groans, sounds that carry for kilometers in the still mountain air. The Kawarau Gorge reveals gold in its geology, formed 15 million years ago when superheated water circulated through deep rock fractures. This hot fluid deposited quartz veins containing gold in concentrations that sparked Central Otago's gold rush. The gold formed when the Pacific Plate began sliding under the Australian Plate, creating heat and pressure that mobilized minerals from deep rocks. Today, you can still see these white quartz veins cutting through gray schist in the gorge walls, some containing visible gold specks that glitter in sunlight. The river below continues to concentrate gold in its gravels, sorted by current into deposits that modern miners still work. The gorge changes color through the day: gray at dawn, golden at noon when sun hits the schist, purple at sunset when shadows fill the depths. Wine grapes now grow on terraces above the gorge, their roots reaching into soil enriched by the same geological processes that created the gold. The combination seems fitting, both wine and gold requiring patience, earth, and time. Lake Wakatipu exhibits a peculiar rhythm, its water level rising and falling 12 centimeters every 25 minutes like clockwork. Scientists explain this as a seiche, a standing wave caused by atmospheric pressure changes, but Maori legend tells of a giant whose heart still beats beneath the lake. The lake's Z-shape, unique among world lakes, creates complex water movements that amplify this rhythmic rise and fall. The lake plunges to depths of 380 meters, carved by glaciers that gouged this serpentine trench when ice covered the land. Its waters remain remarkably clear despite the glacial rivers that feed it, the suspended particles settling in quiet bays. The lake never freezes, its depth moderating temperatures even in the coldest winters. Mountains rise directly from its shores, their slopes so steep that rockfalls occasionally trigger small tsunamis. On calm mornings, the lake becomes a perfect mirror, 44 kilometers long, doubling the landscape in reflection so perfect that photographs become puzzles of which way is up. The Coromandel Peninsula holds enough gold in its rock to theoretically produce another 10 million ounces, though most remains locked in hard quartz beyond economic reach. This gold formed through volcanic processes different from elsewhere in New Zealand, hot springs depositing precious metals in concentrations that still excite prospectors. The Martha mine at Waihai continues operating, following gold veins deep underground, while abandoned mines throughout the peninsula slowly fill with water that turns orange from dissolved minerals. Old mining tunnels honeycomb the hills, some extending kilometers underground, their entrances now hidden by regenerating forest. Battery sites where rock was crushed to extract gold remain as concrete ruins, slowly being reclaimed by Nicao palms and tree ferns. Mercury used in gold processing still contaminates some streams, a toxic legacy that will persist for centuries. Modern technology can detect gold that 19th century miners missed, leading to renewed interest in areas thought exhausted. The peninsula's geology continues forming gold even now, with hot springs depositing microscopic amounts that might, given millions of years, create new ore bodies. Doubtful Sound stretches 3 times longer than Milford Sound, reaching 40 kilometers inland through walls of granite and gneiss. Despite its name, it's a fjord, carved by glaciers not rivers, plunging to depths of 421 meters. The fjord contains 3 distinct arms, each with its own character. One receives so little sunlight that moss grows at sea level. Another opens wide enough for winds to create substantial waves. The deep water appears black, stained by tannins from the surrounding rainforest, creating an environment where deep sea species live close to the surface. Spanish explorers named it Malaspina Reach, while Captain Cook doubted his ability to sail back out against prevailing winds, hence doubtful. The fjord's isolation, accessible only by boat across Lake Manapuri or by air, keeps it quieter than Milford, preserving an atmosphere of profound solitude. Bottlenose dolphins live here year-round, a pod so isolated they've developed distinct behaviors found nowhere else. The silence in Doubtful Sound is remarkable, broken only by bird calls and the occasional splash of a penguin or seal. The Canterbury Plains spread from the southern Alps to the Pacific Ocean, built from 2,000 meters of gravel and sand eroded from mountains over 2 million years. This enormous volume of sediment tells the story of ice ages and warming periods, each layer recording different climatic conditions. Braided rivers created the plains, constantly changing course, depositing load after load of mountain debris. Drill through the plains and you find alternating layers of different-sized particles, boulders from floods, fine silt from quiet periods, arranged like a geological layer cake. The flatness is deceptive. The plains actually tilt gently eastward, dropping about 5 meters per kilometer, invisible to the eye, but enough to keep rivers flowing. Artesian water flows through gravel layers deep underground, confined between impermeable rock, creating pressure that forces water up when wells are drilled. From the air, the plains look like a patchwork quilt of different greens and golds, agricultural geometry imposed on what was once vast grassland where moa grazed. Mount Ruapehu's crater lake undergoes mysterious heating cycles, warming from 15 to 60 degrees Celsius over periods of months without erupting. This lake sits at 2,500 meters elevation, containing 2 million cubic meters of acidic water that would be snow and ice at this altitude without volcanic heat. The lake water is more acidic than vinegar, colored gray-green by suspended sulfur and dissolved minerals. Scientists monitor its temperature constantly, as rapid heating often precedes eruptions. The lake has emptied catastrophically several times, sending lahars, volcanic mudflows, racing down valleys, destroying bridges and forests. Between eruptions, the lake maintains an uneasy equilibrium, heat from below balanced by heat loss to the atmosphere. Steam often obscures the lake surface, and the smell of sulfur carries on the wind for kilometers. In winter, snow falls directly into the hot water, creating clouds of steam that rise thousands of meters. The lake represents the volcano's mood: calm blue-green during quiet periods, gray and roiling when the mountain stirs. Kahurangi National Park protects New Zealand's oldest rocks, granite formations that crystallized 500 million years ago, when complex life was just beginning in Earth's oceans. These ancient rocks, among the oldest in the southern hemisphere, formed deep in the crust when New Zealand didn't exist as a separate landmass. Time and tectonic forces have lifted them to the surface, where they now form rugged mountains. The granite weathers differently than younger rocks, creating distinctive dome shapes and balanced boulders. Some surfaces show striations carved by glaciers that melted 15,000 years ago. The park's caves formed in limestone much younger than the granite, only 40 million years old, creating a landscape where different geological eras exist side by side. Rivers here run clear even after rain, as the hard granite resists erosion. The age of these rocks puts human time in perspective. They formed before fish evolved, before plants colonized land, when Earth was an alien world. Walking among them feels like touching deep time, connecting with an Earth that preceded almost everything we consider ancient. Piha Beach spreads its black iron sand along Auckland's west coast, sand that becomes too hot to walk on during summer afternoons, reaching 60 degrees Celsius in direct sunlight. This sand contains titanium magnetite, eroded from volcanic rocks of the Taranaki and Taupo regions, carried north by ocean currents over thousands of years. The iron content makes the sand magnetic. Running a magnet through it collects black grains that align with magnetic fields. This same iron gives the sand its heat-absorbing properties, storing solar energy like millions of tiny batteries. The beach changes shape seasonally. Winter storms strip sand away, exposing underlying rock platforms, while summer swells rebuild the beach, sometimes overnight. Lion Rock, a volcanic plug, divides the beach, creating different conditions on either side. One side might have perfect surf while the other remains calm. The black sand contrasts dramatically with white foam from breaking waves, creating a monochrome landscape that photographers love. At night, the sand releases its stored heat slowly, keeping the beach warmer than white sand beaches, creating unique conditions where people walk barefoot in winter. The Clutha River carries more water than any other New Zealand river, discharging 614 cubic meters per second into the Pacific Ocean. This massive flow comes from a catchment spanning central Otago's mountains, collecting snowmelt and rainfall from an area larger than some countries. The river's name comes from Clwyd, Scottish Gaelic for the River Clyde, named by homesick Scottish settlers. Despite its volume, the river flows remarkably steadily, regulated by lakes along its course that buffer floods and droughts. Gold miners once diverted entire sections of the river to work the gravels beneath, engineering feats that seem impossible with 19th century technology. Today, the river powers hydroelectric stations that generate enough electricity for hundreds of thousands of homes. The river mouth forms the largest river delta in New Zealand, constantly growing as sediment accumulates. During floods, the river turns brown with suspended sediment, carrying the Southern Alps to the sea particle by particle. From source to mouth, the river drops 800 meters over its 338-kilometer journey. Great Barrier Island exists on its own piece of continental shelf, a fragment that separated from mainland New Zealand 20 million years ago during massive crustal stretching. This isolation created unique ecological conditions. The island has no possums, stoats, or deer, allowing native forests to grow as they did before human arrival. The island's geology differs from nearby mainland, with older volcanic rocks and hot springs that suggest different underground conditions. Without reticulated electricity until recently, the island developed, independently, its communities shaped by isolation and self-sufficiency. Dark skies here reveal stars invisible from light-polluted mainland, earning recognition as a dark sky sanctuary. The island creates its own weather patterns, often receiving rain when Auckland remains dry, or basking in sunshine while storms lash the mainland. Ancient kauri logs lie buried in its swamps, preserved for 50,000 years, their wood still workable despite their age. The surrounding waters mix warm East Auckland current with cooler coastal waters, creating marine conditions that support both tropical and temperate species. From its heights, you can see the curve of Earth's horizon, a reminder of this island's position at the edge of the continental shelf. The Homer Tunnel cuts through solid granite beneath the main divide, a passage that took 19 years to complete using hand tools and explosives. The tunnel descends at a gradient of 1 in 10, so steep that water runs through it like a river during rain. Workers carved this tunnel in conditions of perpetual cold and wet, with avalanches claiming several lives during construction. The eastern portal sits in alpine meadows, while the western end opens into temperate rainforest, the tunnel connecting two different worlds in just 1.2 kilometers. Ice forms inside during winter, creating hazardous conditions as water dripping from the ceiling freezes on the road. The tunnel remains unlined, raw granite visible in the headlights, with bolts holding back loose rocks that occasionally still fall. Traffic lights control one-way flow, as the tunnel is too narrow for two-way traffic. Kia, alpine parrots, have learned the traffic light timing and gather at portals, entertaining waiting tourists. The achievement seems impossible even by modern standards, drilling through a mountain using 1930s technology in one of the world's wettest, most avalanche-prone locations. Lake Pukaki glows with a turquoise color so vivid it appears artificial, caused by glacial flour. Rock particles ground so fine they remain permanently suspended in the water. These particles, smaller than smoke particles, scatter light in a way that creates this distinctive color. The lake formed when glaciers retreated, leaving a depression dammed by glacial moraine. Its level now fluctuates artificially, controlled for hydroelectric generation, rising and falling meters depending on power demand. The glacial flour comes from the Tasman and Hooker glaciers grinding bedrock in the mountains above. This suspended sediment never fully settles, kept in suspension by molecular forces and water movement. The lake's color changes with the angle of sunlight, brilliant turquoise at midday, darker blue in evening, sometimes appearing almost white when clouds reflect in its surface. Mount Cook reflects perfectly in the lake on calm days, its image tinted turquoise by the water. The flour is so fine that filtering the water is nearly impossible. It passes through most filters, remaining suspended indefinitely. The Rimataka Range rises so abruptly from sea level that it creates a wind tunnel effect, accelerating winds through Cook Strait to speeds exceeding 200 kilometers per hour. These mountains force weather systems to rise sharply, creating dramatically different conditions on either side. The western Wairarapa might bask in sunshine, while Wellington, just 30 kilometers away, endures gales and rain. The range acts like a meteorological wall, blocking or funneling weather systems depending on their direction. The old coach road over the range, now a walking track, shows how challenging this barrier was before modern tunnels. Wind here has shaped everything. Trees grow stunted and bent, birds fly at angles to make progress, and even rocks show wind erosion patterns. The railway that once climbed over the range used a unique fell engine system, the only one outside England, necessary to climb grades that defeated conventional trains. Today's road tunnel bypasses the worst winds, but emergence from either portal can surprise drivers with sudden gusts that weren't present inside. Waipua Forest protects Tane Mahuta, a kauri tree whose trunk contains 244 cubic meters of wood, making it New Zealand's largest tree by volume. This giant has stood for approximately 2,000 years, predating human arrival in New Zealand. Its trunk rises 17 meters before the first branch, creating a column of wood larger than most entire trees. The tree creates its own ecosystem. Its bark hosts orchids and ferns. Its canopy shelters birds found nowhere else. Its roots extend farther than its height. Kauri trees like Tane Mahuta change soil chemistry, creating acidic conditions that prevent other species from competing. The tree's resin, bleeding from wounds, accumulates in soil and can be dug up thousands of years later, preserved like amber. Standing before Tane Mahuta induces a particular silence in visitors, an acknowledgement of encountering something that has witnessed centuries. The tree survived the logging that destroyed 99% of kauri forests, protected by its remote location, and Maori, who recognized its significance. Every year, its trunk expands by mere millimeters, growth so slow it's invisible to human perception. The Wanganui River became the world's first river, granted legal personhood in 2017, recognized as a living entity with rights equivalent to a person. This legal status acknowledges what Maori always knew. The river is an ancestor, inseparable from the people who live along its banks. The river flows for 290 kilometers from Mount Tongariro to the Tasman Sea, New Zealand's longest navigable river. Its journey includes rapids, gorges, and gentle meadow sections where it loops back on itself. The river carved its path through soft papa mudstone, creating cliffs that regularly collapse, turning the water muddy, brown. Paddle steamers once navigated far inland, connecting remote communities before roads existed. The river's legal status means harming it is equivalent to harming a person, a recognition that rivers are more than water between banks. They're living systems that include everything from source to sea. This precedent has influenced similar recognitions worldwide, acknowledging that natural features deserve protection not as property, but as entities with intrinsic rights. Cape Ringa marks where two great bodies of water meet in perpetual confrontation. The Tasman Sea and Pacific Ocean collision creates a visible line of turbulence extending from the cape, where different temperature waters refuse to immediately mix. This meeting of waters holds deep significance in Maori tradition. Spirits depart here for their homeland, leaping from the ancient Pohutukawa tree that clings to the cliff. On clear days, you can see the Three Kings Islands, stepping stones to the tropical Pacific. The Cape experiences winds that rarely cease, shaped by the pressure differences between the two ocean systems. The lighthouse, automated now, stands where its beam reaches ships 35 kilometers at sea. Below the Cape, underwater canyons plunge to depths unmapped, carved by currents that sweep around New Zealand's northern tip. Standing here feels like standing at an edge, not just of land, but of something more fundamental, where forces that shaped these islands continue their ancient dispute, neither ocean yielding, both forever advancing and retreating in tidal rhythms. The Franz Josef Glacier surges forward at rates that astonish glaciologists, advancing up to 4 meters per day during active periods. This movement is 10 times faster than typical glacier flow, caused by the exceptional snowfall in the Neve feeding the glacier. The glacier receives up to 50 meters of snow annually at high elevations, compressed into ice that must flow downward. During surge periods, the glacier makes cracking sounds audible kilometers away as crevasses open and close. The ice moves so fast that features change daily. Seracs that stood yesterday collapse today. Crevasses appear overnight. This rapid movement brings ice from high elevations to the terminus quickly, meaning the ice melting at the glacier face fell as snow just 7 years ago, compared to centuries for most glaciers. The glacier has advanced and retreated repeatedly, sometimes reaching the forest, other times withdrawing kilometers up valley. Trees grow where ice stood decades ago, while ice now covers where forests grew centuries past. This dynamism makes Franz Josef a living demonstration of how climate and glaciers interact in real time rather than geological time. Lake Horoko plunges to depths of 462 meters, so deep that Auckland's Sky Tower could be submerged completely with 134 meters of water still above its tip. This depth creates water of extraordinary clarity in the upper layers, while the depths remain in permanent darkness, where no sunlight has penetrated for thousands of years. The lake formed in a glacially carved valley, its walls dropping almost vertically beneath the surface. The deepest parts have never been fully explored, their waters too cold and pressure too great for casual diving. Maori named it sounding wind for the winds that funnel through the valley, creating waves on otherwise calm days. The lake's depth affects its ecology. The bottom waters never mix with the surface, creating distinct layers with different temperatures and oxygen levels. Ancient logs lie preserved in the oxygen-poor depths, wood that sank centuries ago, remaining intact in the cold darkness. The surrounding forest grows right to the water's edge, creating reflections so perfect that the lake seems to hold an inverted forest beneath its surface, extending down into depths no tree could actually reach. Egmont National Park creates a perfect circle of protected forest around Mount Taranaki, its boundary forming a geometric shape visible from space as a green disk against surrounding farmland. This circle, 19 kilometers in radius, exists because early surveyors simply drew a compass circle on a map, creating one of the world's most geometrically perfect park boundaries. Inside this circle, the forest changes with altitude in concentric rings, Rata and Rimu near the boundary, Kamahi and Totara higher up. then alpine shrubs, and finally, bare rock and ice. The circular boundary creates an island of biodiversity, protecting species that have vanished from surrounding areas. Rain falls differently inside and outside the circle. The mountain creates its own precipitation patterns, so the park might be drenched while farms just beyond the boundary remain dry. This perfect geometry imposed on nature creates an unusual experiment, a precise circle of wilderness surrounded by agriculture, like a giant petri dish of conservation. Walking from farmland into the park feels like crossing an invisible wall. The temperature drops, bird songs change, and the air itself feels different. Aotearoa sits within a caldera 22 kilometers wide, formed by an eruption 240,000 years ago that ejected 340 cubic kilometers of material. The city exists inside this ancient volcanic collapse. Though the caldera is so large, most residents don't realize they're living in a volcano. The eruption that created this depression would have been visible from space, ejecting ash that fell across the entire North Island. Today, the caldera floor hosts lakes, hot springs, and the city itself, all contained within the circular rim of ancient collapse. Thermal activity continues everywhere. Steam rises from drains, hot pools bubble in backyards, and some residents heat their homes with geothermal bores in their gardens. The ground itself is warm in places, and construction requires special techniques to avoid drilling into steam pockets. Living here means accepting that the earth beneath remains active, occasional earthquakes, the smell of sulfur after rain, and the knowledge that this calm is temporary on geological timescales. The caldera continues to breathe, rising and falling millimeters over years as magma moves far below. The Buller River Gorge exposes gold-bearing quartz veins that have produced over 2 million ounces since mining began in 1860. These veins formed when superheated water, heated by deep crustal processes, dissolved gold from surrounding rocks and redeposited it in concentrated form. The white quartz stands out against dark argillite, creating a natural map of ancient fluid pathways. Some veins run for kilometers, disappearing into mountainsides where miners followed them underground. The gorge walls tell stories of geological violence, rocks twisted and folded by tectonic forces, then carved by the river into vertical walls. Gold still washes from these veins during floods, concentrated by the river into deposits that weekend prospectors still work. The gorge changes color through the day as sunlight moves across it. Morning shadows hide the depths, while afternoon sun lights the western walls gold. Old mining equipment rusts along the river, slowly being reclaimed by forest, while new technology allows modern miners to rework deposits once thought exhausted. The river continues its patient work, grinding mountains into sand, concentrating gold grain by grain. Mount Maunganui rises from a base of solid rhyolite lava that cooled 2.5 million years ago, now surrounded by sand dunes only 6,000 years old. This volcanic dome once stood as an island, but ocean currents built a sand bridge connecting it to the mainland, creating one of New Zealand's most popular beaches. The mountain itself is the solidified core of an ancient volcano, its harder rock resisting erosion while softer surrounding material washed away. Walking its slopes, you step on rock that once flowed as lava, now fractured into blocks that shift underfoot. The summit offers views where 3 different geological ages are visible: the ancient volcanic plateau inland, the recent sand deposits of the coast, and the active volcanic white island smoking on the horizon. The mountain creates its own microclimate, forcing sea breezes upward where they cool and sometimes form a cap of clouds just on the summit. Archaeological evidence shows Maori occupied the mountain for centuries, using its strategic position to watch for threats or opportunities from land and sea. The Poor Knights Islands harbor underwater caves large enough to fit a Boeing 737, carved by millions of years of wave action into volcanic rock. These caves extend deep into the islands, creating a labyrinth of passages, chambers, and tunnels that divers are still mapping. The largest cave, Rikoriko, spans more than 200 meters long with a ceiling 30 meters high. Light enters through underwater openings, creating cathedral-like illumination that changes with the sun's angle. The caves formed when lava tubes and gas bubbles in volcanic rock were exposed to wave erosion, gradually enlarging over millennia. Inside, the water clarity exceeds 30 meters, allowing sunlight to penetrate deep into the caves. The acoustic properties create an otherworldly environment where whale songs from kilometers away echo through the chambers. These caves host species found nowhere else, evolved in the unique conditions of partial darkness and surge. The islands above remain uninhabited, their forests recovering from centuries of Polynesian rat impact, while below, the caves continue their slow enlargement, grain by grain. Lake Te Anau spreads across 344 square kilometers, but its complex shape creates 500 kilometers of shoreline, more coastline than many small countries possess. 3 major arms extend from the main lake, each reaching deep into the mountains like fjords filled with fresh water. The lake's complicated geometry resulted from glacial carving, where multiple glaciers converged, each gouging its own valley before melting to leave this branching system. Hidden beaches accessible only by boat line remote shores where the forest has never been logged. The lake contains several underground streams that flow through limestone, disappearing into the earth and emerging in unexpected places. Its waters remain remarkably stable in temperature year-round, the enormous volume moderating seasonal changes. From above, the lake resembles a giant hand pressed into the landscape, fingers reaching toward different mountain ranges. Navigation requires careful attention. What looks like continuous shoreline might be an island, and apparent dead ends often open into new arms. The complexity creates countless sheltered bays where the water lies still as glass even during storms. The Taupo volcanic zone generates enough geothermal energy to power 700,000 homes, with underground reservoirs reaching temperatures of 350 degrees Celsius. This zone stretches from White Island to Mount Ruapahu, a belt of volcanic activity where the Earth's crust thins to just 15 kilometers. Steam vents, hot springs, and geysers mark where this underground heat reaches the surface. Power stations tap this energy through boreholes that penetrate thousands of meters, bringing superheated water and steam to turbines. The zone produces more than just electricity. Minerals precipitate from cooling geothermal waters, creating colorful terraces and deposits. Some areas are too hot for any development, where the ground itself can melt boot soles. The heat comes from magma bodies just 5 to 10 kilometers below, closer to the surface here than almost anywhere else on Earth. This thermal activity has shaped human settlement for centuries. Maori used hot pools for cooking and bathing, while modern cities depend on the electricity generated from Earth's heat. Ship Creek near Haast contains black sand deposits worth billions of dollars in ilmenite, a titanium-bearing mineral eroded from schist rocks inland. These deposits formed over thousands of years as rivers carried heavy minerals from the southern Alps, concentrated by wave action along the beach. The black sand forms distinct layers, sometimes pure enough to attract magnets. Mining proposals have repeatedly emerged and been rejected, the value balanced against environmental concerns. The creek mouth changes position with each major storm, sometimes flowing north, sometimes south, as sand barriers redirect its course. During certain tides and wind conditions, the black sand becomes airborne, creating dark clouds that sandblast anything in their path. The deposits extend offshore, where underwater dunes of black sand migrate with ocean currents. This sand is part of a larger system of mineral deposits along the west coast, formed by the same processes of erosion and concentration. Walking here, your footprints fill with water that appears black from the dissolved minerals, creating temporary pools that reflect the sky like dark mirrors. Aotearoa Harbor fills an ancient volcanic crater, the sea having flooded what was once a lava-filled caldera. The volcano that created this harbor erupted 6 million years ago, part of the volcanic complex that built Banks Peninsula. The harbor's shape, nearly circular with a narrow entrance, reveals its volcanic origin, while the surrounding hills are the eroded remnants of the crater rim. French settlers arrived here in 1840, days after British sovereignty was declared, creating New Zealand's only French settlement. Their influence persists in street names and architecture that seems transplanted from Brittany. The harbor's volcanic geology creates exceptional fertility in surrounding soils, decomposed basalt, providing minerals that support gardens and farms. Deep water extends almost to the shore, allowing large ships to anchor where crater walls plunge steeply underwater. The harbor acts as a sun trap, its bowl shape creating a microclimate several degrees warmer than exposed coasts. Hector's dolphins, the world's smallest dolphins, live here year-round, finding shelter in the harbor's protected waters. Mount Aspiring's Bonar Glacier has retreated 2.5 kilometers since 1880, leaving behind a valley of exposed bedrock and glacial debris. The retreat reveals landscapes hidden under ice for millennia, polished rock surfaces, glacial striations, and moraines that mark former ice positions like bathtub rings. Where ice stood a century ago, pioneer plants now colonize bare rock, beginning the slow process of soil formation. The glacier continues retreating about 30 meters annually, though the rate varies with seasonal snowfall. Meltwater from the glacier runs milky with rock flour, joining streams that eventually reach the ocean, carrying the mountain particle by particle to the sea. The newly exposed valley contains features that demonstrate glacial processes: roches, moutonnées sculpted by ice, erratics dropped far from their source, and kettle lakes where buried ice blocks melted. This retreat is recorded in photographs spanning decades, each showing less ice, more rock, a mountain gradually revealing its bones. Walking up the valley, you travel forward in time, from bare rock recently exposed to established vegetation where ice melted decades ago. Hokianga Harbor reaches far inland through a narrow entrance guarded by enormous sand dunes that tower 400 meters above the water. These dunes migrate inland about 5 meters each year, burying forests and revealing ancient soils. The harbor formed when rising seas flooded a river valley, creating a branching waterway that extends 25 kilometers inland. The entrance bar shifts constantly, making navigation treacherous. Numerous ships lie wrecked in the sand, gradually being exposed and buried with each tide. Giant kauri logs, some thousands of years old, wash from eroding banks, preserved in mud since ancient forests fell. The harbor's upper reaches become tidal mudflats twice daily, exposed expanses where thousands of birds feed. Mangroves grow at their southern limit here, creating underwater forests that appear and disappear with tides. The sand dunes on the north head glow golden at sunset, their massive scale dwarfing people who climb them. Local Maori say the harbor is where Kupe, the legendary navigator, departed New Zealand, and the entrance does feel like a gateway between worlds. Lake Ellesmere exists in constant tension with the sea, separated from the Pacific Ocean by Kaitoreti Spit, a gravel barrier just 50 meters wide in places. This barrier beach, built from river gravels transported by longshore drift, dams the lake, which periodically breaks through during floods. The lake expands and contracts dramatically, sometimes covering 200 square kilometers, other times shrinking to half that size. Its waters remain brackish, a mix of fresh water from inland rivers and salt water that seeps through the gravel barrier. The lake is rarely more than 3 meters deep, so shallow that wind can push water from one side to the other, exposing vast mudflats. These conditions create a unique ecosystem supporting thousands of birds, including species that migrate from the Arctic. Human intervention periodically opens the barrier to prevent flooding, releasing lake water in controlled bursts that temporarily turn the sea brown with sediment. The barrier itself migrates slowly inland, pushed by storms, gradually drowning farmland that was once lake bed, then dry land, and will be lake bed again. The Richmond Range contains ultramafic rocks with naturally occurring asbestos minerals, creating mountains that appear green from certain angles. These rocks, formed in Earth's mantle, brought to the surface by tectonic collisions containing minerals rare in surface rocks. The high magnesium content creates soils toxic to most plants, supporting only specialized species adapted to these harsh chemical conditions. The green color comes from serpentine minerals, giving entire mountainsides an unusual jade-like appearance. These rocks weather differently than surrounding stones, creating a landscape of sharp ridges and unusual formations. Mining operations once extracted asbestos here before its dangers were understood, leaving abandoned workings slowly being reclaimed by specialized vegetation. The ultramafic rocks also contain traces of platinum, chromium, and nickel, concentrated by geological processes over millions of years. Walking these mountains requires care. The fibrous minerals can become airborne when disturbed. Rain weathers these rocks into clays that become dangerously slippery, creating natural slip zones where entire hillsides occasionally collapse. Pelorus Bridge swimming hole maintains a constant 8 degrees Celsius year-round, fed by snowmelt from mountains 40 kilometers away. The river has carved deep pools in solid rock, creating chambers where the water turns deep green from minerals dissolved from schist bedrock. The cold is shocking. Swimmers last minutes rather than hours, and the body's response is immediate and involuntary. Yet people return repeatedly, drawn by water so clear you can see every pebble on the bottom 10 meters down. The river maintains its flow even in drought, fed by snow that accumulates in high valleys and melts slowly through summer. Trees lean over the pools, creating shadowed depths where eels grow to remarkable size in the cold, nutrient-rich water. The bridge itself, built in 1902, spans a gorge carved through rock layers that tell stories of ancient seas and mountain building. Below the bridge, kayakers navigate rapids that change with rainfall, reading water patterns that indicate hidden rocks. The constancy of temperature speaks to the river's mountain origins, carrying winter with it even in summer. The Catlin's coast preserves another fossilized forest at Porpoise Bay, distinct from Curio Bay, where 160-million-year-old tree stumps appear for just 2 hours during spring low tides. These trees grew in the Middle Jurassic, in a climate much warmer than today's, when New Zealand was part of Gondwana. The fossilization process replaced wood with silica so perfectly that growth rings and bark patterns remain visible. Some stumps stand exactly where they grew, while fossilized logs lie pointing in the same direction, suggesting they all fell in the same ancient storm or volcanic event. Walking among them requires precise timing. Arrive too early and they're underwater, too late, and the returning tide covers them again. The surrounding rock contains fossilized ferns and cycads, plants that grew in the forest understory. This glimpse into deep time lasts briefly before the ocean reclaims it, as it has twice daily for thousands of years. Each tide wears away a tiny bit more, gradually erasing this stone forest that has already survived longer than our species has existed. Mount Ngauruhoe stands as the youngest vent of the Tongariro complex, a perfect volcanic cone just 2,500 years old. Movie audiences know it as Mount Doom, though its actual history is even more dramatic, erupting every few years through most of the 20th century, throwing lava bombs that still litter its slopes. The cone built itself through successive eruptions, each adding layers of ash and lava that created its symmetrical shape. Climbing it means ascending loose scoria that slides with each step, taking 3 steps to make 1 step's progress. The summit crater drops vertically into darkness, occasionally venting steam that reminds climbers this mountain only sleeps. Red crater nearby demonstrates what Ngauruhoe might become. Blown apart by eruptions, its perfect cone destroyed. The mountain creates its own weather, clouds forming on its peak, even on clear days. Snow lingers in shadowed gullies through summer, creating a patchwork of black rock and white snow. From its summit, you can see the volcanic lineage of the North Island, Ruapahu, Taranaki, even distant Mount Edgecumbe, all part of the Pacific Ring of Fire. The Avon Heathcote estuary processes 8 million cubic meters of tidal water twice daily, the entire estuary filling and emptying like a vast lung breathing with the ocean. This breathing filters nutrients through 800 hectares of mudflats, supporting millions of organisms from microscopic bacteria to large wading birds. The estuary formed when rising seas flooded the lower reaches of 2 rivers, creating a mixing zone where fresh and salt water create constantly changing conditions. Twice daily, the mudflats emerge, revealing a landscape that looks alien. Channels like veins, pools reflecting sky, and millions of crab holes that bubble and pop. The mud itself lives, packed with organisms that process nutrients, creating one of the most productive ecosystems per square meter on Earth. The estuary acts as Christchurch's kidneys, filtering runoff from the city, though this function has limits. Excess nutrients cause algal blooms that turn water green. Birds arrive with the tides, their feeding synchronized to water levels, some species feeding on the falling tide, others on the rising. This rhythm has continued for thousands of years, unbroken even by earthquakes that razed parts of the estuary in 2011. Queen Charlotte Sound contains sunken river valleys that dropped below sea level 12,000 years ago when ice sheets melted worldwide, raising oceans by over 100 meters. The Sound's complex shape, a main channel with numerous arms and bays, reveals the drowned river system, with former tributaries now separate inlets. The depth varies dramatically from shallow bays to channels over 300 meters deep where the main river once flowed. Ancient Maori knew these waters intimately, navigating by reading currents that still follow old river paths. Captain Cook returned here repeatedly, using Ship Cove as a base, drawn by shelter and fresh water. The Sound creates its own circulation patterns, with tidal flows so complex that water can flow different directions on opposite sides of the same bay. Sunken forests occasionally appear at extremely low tides, stumps of trees that grew when sea levels were lower, The surrounding hills show ancient shorelines as terraces, marking where seas stood at different periods. This drowned landscape continues evolving as sediment from surrounding hills gradually fills the deeper channels, slowly returning the sound to land. The Denniston Plateau sits 600 meters above sea level, yet marine fossils in its rocks prove it lay underwater 35 million years ago. This plateau lifted from the seafloor through tectonic forces, raised so gently the rock layers remain nearly horizontal. Coal formed here when the plateau was a vast swamp, compressed vegetation now extracted through mining that has left an industrial archaeology across the plateau. The Denniston Incline, an engineering marvel of its time, lowered coal wagons down a slope so steep it seemed impossible. Weather here is harsh. Clouds envelop the plateau for days, rain falls horizontally, and snow can come any month. The vegetation adapted to these conditions grows nowhere else. Cushion plants that hug the ground, orchids that bloom in fog, and stunted trees centuries old but only meters tall. The plateau feels like another world, often above the clouds while valleys below remain hidden. Wind-sculpted sandstone creates formations that seem architectural, while old mining equipment rusts into abstract sculptures. This landscape of coal and cloud, limestone and lichen, exists in a perpetual state of harsh beauty. Lake Waikaremoana formed just 2,200 years ago when a massive landslide sealed a river valley, creating one of New Zealand's younger lakes. The landslide, triggered by an earthquake, moved an entire mountainside in seconds, dropping millions of tons of rock and earth across the valley. The river, finding its path blocked, slowly filled the depression behind this natural dam, drowning forests that still stand as ghostly skeletons in shallow bays. The lake's name means sea of rippling waters, describing how wind patterns create waves that seem to come from nowhere on calm days. The dam itself remains unstable, slowly eroding where water overtops it in a spectacular waterfall. Scientists monitor this natural dam constantly, knowing that its eventual failure could release the entire lake catastrophically. For now, the lake remains, its waters deep and cold, surrounded by the Aotearoa forests. The cliffs around the lake show the scar where the mountain collapsed, a vertical face of exposed rock that weathers too slowly for vegetation to establish. Maori speak of taniwa in these waters, and on misty mornings when drowned trees emerge from fog, the presence of something ancient feels entirely possible. The Taieri River performs a geological rebellion, traveling 288 kilometers to reach the sea just 80 kilometers from where it began. This wandering path follows ancient fault lines and captures by other rivers, creating New Zealand's most meandering waterway. The river crosses the rock and pillar range through a gorge, then spreads across the Taieri Plains in loops so pronounced that some nearly complete circles. From above, the river looks like a child's scribble across the landscape, doubling back on itself repeatedly. These meanders create billabongs, abandoned river loops that become crescent-shaped lakes when the river cuts a new, shorter path. The river gradient is so gentle across the plains that tides affect water levels 60 kilometers inland. During floods, the entire plain can become a shallow lake, the river reclaiming its historical bed. Farmers have tried to straighten sections, but the river remembers its curves, flooding in patterns that follow ancient channels. This patient wandering has created New Zealand's only true plains, where the horizon seems endless and the river takes its time, as if the sea can wait. Oamaru's Victorian precinct rises from foundations of local limestone that transforms into gold at sunset. This limestone, called Oamaru stone, contains 30% calcium carbonate from countless marine organisms compressed on an ancient seafloor. The stone is soft when quarried, easily carved into elaborate decorations, but hardens with exposure to air. Entire streets here are built from this single material, creating an architectural unity rare in New Zealand. The limestone's porosity allows it to breathe, absorbing and releasing moisture, which helps preserve the buildings. As the sun sets, the stone's cream color warms to honey, then deep gold, making the entire precinct glow as if lit from within. Fossils appear in building walls, shells, sea urchins, and shark teeth embedded in facades, reminders that these Victorian buildings are constructed from ancient ocean floor. Penguins nest beneath some buildings, finding the limestone caves beneath foundations perfect for their needs. The same stone that builds the human city above creates a penguin city below, two worlds separated by floorboards but united by geology. The Kaikoura Canyon plunges from just 500 meters offshore into an abyss reaching 1.5 kilometers deep. This underwater chasm rivals terrestrial canyons in scale, but remains invisible from shore, its presence known only through sonar mapping. The canyon head approaches so close to land that deep-sea creatures, normally found far offshore, swim within sight of beaches. Sperm whales hunt giant squid in the canyon depths, surfacing where tourists in small boats wait. The canyon formed through a combination of tectonic activity and underwater avalanches, carved by turbidity currents that race down its walls at highway speeds. Nutrients upwell from the depths, creating a food chain that supports everything from krill to blue whales. The canyon continues beyond its mapped extent, joining other submarine valleys in a network that extends to the abyssal plain. During earthquakes, sections of canyon wall collapse, triggering underwater avalanches that generate tsunamis. Scientists lower instruments into the canyon to study deep-sea life, each deployment revealing species new to science. This hidden geography shapes everything above it: the currents, the wildlife, even the weather patterns influenced by cold water rising from the depths. Mount Hikurangi on the East Cape greets each new day before anywhere else in New Zealand, receiving first light 46 minutes before Auckland. This eastern position makes it a place of beginnings, where Maori tradition says the sun's rays first touch the earth. The mountain rises to 1,700 meters, not remarkably high, but its position makes it special. On clear mornings, the summit glows pink while valleys remain in darkness, a daily transformation that lasts just minutes. The mountain is considered so sacred that climbing requires permission from local iwi, who maintain that some places should remain untouched by casual footsteps. Snow sometimes caps the peak, even in summer, creating a beacon visible from far at sea. The mountain catches moisture from the Pacific, creating its own rain shadows and cloud formations. From its slopes flow rivers that reach both east and west coasts, waters divided by the summit eventually reaching different seas. Standing here at dawn feels like witnessing creation itself, the world emerging from darkness piece by piece as light spreads westward across the land. The Wangehu River flows orange and acidic from its source on Mount Ruapahu, maintaining a pH similar to lemon juice for most of its length. This acidity comes from volcanic minerals dissolved from the crater lake, creating water that would kill most life. Yet somehow, specialized bacteria and algae thrive here, adapted to conditions that would dissolve ordinary organisms. The river's color changes with volcanic activity, bright orange when the crater lake is active, clearer when volcanic input decreases. After heavy rains, the river can turn white with suspended aluminum compounds, creating a river of milk flowing through green pastures. Bridges crossing the river corrode faster than normal, metal dissolving in the acidic water. Farmers avoid letting stock drink from it, though dilution eventually neutralizes the acid before it reaches the sea. During the 1953 Lahar, this river carried a wall of volcanic mud that destroyed a railway bridge, causing New Zealand's worst rail disaster. Today, warning systems monitor warning the river constantly, measuring pH and flow to predict dangerous events. The river reminds us that some waters are not meant for life as we know it. Lake Ohau channels winds through mountain gaps at speeds reaching 130 kilometers per hour. These winds, funneled through the only low pass in the surrounding ranges, accelerate like water through a nozzle. The lake surface transforms from mirror calm to 3-meter waves in minutes when these winds arrive. Trees on exposed shores grow horizontal, shaped by decades of consistent gales. The winds have names here: the northwester that brings rain, the southerly that brings cold, each with its own personality. Sailors study weather patterns obsessively, knowing that conditions can change fatally fast. The lake itself moderates temperatures in the valley, but the winds overwhelm this effect, bringing Antarctic cold or subtropical warmth depending on their origin. In winter, these winds create snowdrifts that close roads, while in summer they fan forest fires. Houses here are built low and strong, windows face away from prevailing winds, and gardens grow only in sheltered spots. The sound of wind becomes the soundtrack to life, sometimes a whisper, sometimes a roar that makes conversation impossible. The Conway River mouth migrates dramatically with each major storm, shifting up to 2 kilometers north or south along the coast. This river can't decide where to meet the sea, its mouth blocked and redirected by gravel barriers built by longshore drift. After floods, the river might break through at an entirely new location, abandoning its previous channel overnight. Maps become outdated within years, showing river mouths where only dry gravel now lies. The river carries vast amounts of sediment from rapidly eroding mountains, depositing it at the coast where waves immediately begin redistributing it. This constant change creates problems for the highway bridge, which must span not just the current river position, but all possible positions. Salmon trying to return to spawn sometimes find their river has moved, circling confused off the wrong stretch of beach. The gravel barriers themselves migrate along shore, growing at one end while eroding at the other, the entire system in constant motion. Local farmers have learned not to develop land near the coast, knowing the river might claim it without warning. Mount Sunday rises from the Rangitata Valley as an isolated hill that seems placed by design rather than nature. This solitary mound is actually glacial moraine, debris deposited by retreating ice 15,000 years ago. While surrounding moraines eroded away, this one persisted, protected by its compact shape and resistant cap rock. The hill stands just 200 meters above the valley floor, but its isolation makes it seem taller, visible for tens of kilometers in every direction. Filmmakers recognized its dramatic potential, transforming it into Adoras, the capital of Rohan. The hill's grasses change color with seasons: green in spring, gold in summer, brown in winter, creating a natural calendar visible from afar. Archaeological evidence shows Maori used it as a lookout, its view encompassing approaches from all directions. Wind shapes everything here, from the lean of fence posts to the growth patterns of the sparse vegetation. Climbing the hill takes just minutes, but the view from the top spans hours of travel in any direction. This geometric perfection in a valley of chaos seems to prove that nature occasionally appreciates symmetry. The Manawatu Gorge exists because a river refused to change course when a mountain range rose in its path. The Manawatu River carved down as fast as the Ruahine Range rose, maintaining its course through 3 million years of uplift. This created a gorge where water flows perpendicular to the mountain range, cutting directly through rather than flowing around. The gorge walls reveal this story in tilted rock layers, showing how the range rose while the river persisted. This persistence created the only low-level passage through the ranges for hundreds of kilometers, making it crucial for transport. The river continues its work, cutting a few millimeters deeper each century, keeping pace with the still rising mountains. Slips regularly close the road through the gorge, entire hillsides collapsing when rain lubricates ancient fault lines. The gorge creates its own weather, funneling winds and clouds, often filled with mist when surrounding areas are clear. Walking through it feels like passing through a gateway, the confined space amplifying river sounds until they fill your consciousness. This is geography in active creation, mountain and river locked in a contest measured in millions of years. Lake Brunner achieves perfect stillness on 200 mornings each year, created by cold air draining from surrounding mountains into the valley. This cold air forms an invisible layer above the water, preventing wind from reaching the surface. The stillness is so complete that insects walking on water create visible ripples extending meters from their tiny feet. These conditions typically occur at dawn, lasting until sunlight warms the air enough to break the inversion layer. Photographers arrive before sunrise, knowing these perfect reflections last only hours. The lake formed when glaciers retreated, leaving a depression that filled with the clearest water, filtered through granite gravels. Kahikatea trees line the shores, their reflections creating corridors that appear to extend infinitely downward. The lake holds brown trout that grow enormous in its food-rich waters, though the mirror surface makes them wary and difficult to catch. When the mirror finally breaks, usually around mid-morning, it happens gradually. First a shimmer, then small wavelets. Finally, proper waves. Local residents gauge the day's weather by how long the morning mirror lasts, knowing that early breaking means wind and possible storms. The Chatham Islands exist 800 kilometers east of mainland New Zealand on their own volcanic plateau, hosting plants and animals found nowhere else on Earth. These islands occupy their own time zone, 45 minutes ahead of New Zealand, the world's earliest inhabited time zone. Isolation has created unique species. The Chatham Island forget-me-not, with flowers larger than dinner plates, the black robin saved from extinction when only 5 birds remained. The islands emerged from the sea through volcanic activity, but unlike mainland New Zealand, they've remained stable for millions of years. This stability allowed evolution to pursue different paths, creating an alternative version of New Zealand biology. Wind dominates everything here. Trees grow in streams, valleys to escape it, and most vegetation hugs the ground. The surrounding seas are rougher than almost anywhere on Earth, waves traveling unimpeded around the Southern Ocean. Moriori people developed a culture here distinct from Maori, shaped by isolation and limited resources. The islands feel like an outpost at the world's edge, where the international dateline nearly grazes the shore, each dawn arriving here before anywhere else humans live. Tunnel Beach near Dunedin hides behind cliffs until you descend through a tunnel hand-carved through solid rock in the 1870s. A local politician had this tunnel carved to create private beach access for his family, a Victorian-era feat of determination over geography. The tunnel drops steeply through sandstone, dark and cool even on summer days, emerging onto a beach that seems designed by an artist. Sea stacks stand like sentinels. Waves carve constantly changing patterns in sand, and the cliffs create an amphitheater of stone. The beach disappears at high tide, waves crashing against cliffs, making timing essential for visits. Erosion continues reshaping this coast, recently collapsing sections of cliff, gradually widening the beach while destroying the headlands. The sandstone layers tell stories of ancient seas and beaches, compressed and lifted, now being returned to sand grain by grain. From the beach, the tunnel entrance appears as a dark eye in the cliff face, the only escape route when tides turn. This hidden beach, accessed through human ambition carved in stone, remains one of Dunedin's most dramatic coastlines. The Ruahine Range nurtures alpine cushion plants that grow as perfect spheres, some over 50 years old yet smaller than soccer balls. These plants, sculpted by constant wind, grow so slowly that annual growth rings are microscopic. They survive where trees cannot, above the bushline where wind strips moisture and soil barely exists. Each cushion plant is actually hundreds of tiny stems, packed so tightly they form a living dome, the dead leaves inside providing the only soil the plant will ever know. The spherical shape minimizes wind resistance while maximizing heat retention. AE survival architecture perfected over millennia. Some cushions are actually multiple species growing together, so intertwined they appear as single organisms. In summer, these living stones burst with tiny flowers, transforming gray-green domes into colorful spheres. Walking among them requires extreme care. A single footstep can destroy decades of growth. The cushions create their own microclimates, interior temperatures several degrees warmer than surrounding air. These patient spheres, growing millimeters per decade, represent life at its most persistent, thriving where survival seems impossible. Lake Kinnear takes 7 years to completely cycle its water, filtered through 8 meters of annual rainfall in surrounding forests. This slow circulation creates water of exceptional purity, each drop spending years traveling through forest soils before entering the lake. The surrounding vegetation acts as a living filter, removing nutrients and sediments, creating water so clear that sunlight penetrates to remarkable depths. The lake formed when glaciers retreated, leaving a depression that filled with this filtered forest water. Ancient kahikatea and rimu trees line its shores, some over 1,000 years old, their roots extending into the lake itself. The slow water cycle means pollution would take years to flush out, making the lake vulnerable despite its remote location. Whitebait spawn in tributaries, their life cycle timed to the lake's seasonal rhythms. The water maintains a constant cool temperature, moderated by the slow exchange and forest shade. On still days, the lake surface becomes dark as tea from dissolved organic matter, yet remains crystal clear beneath. This patient circulation, measured in years rather than seasons, creates an underwater world of extraordinary stability. The Ahuriri River Valley rose 2.5 meters in seconds during the 1931 Napier earthquake, converting 3,000 hectares of lagoon into dry land overnight. Where boats floated the evening before, sheep grazed the next morning. This dramatic uplift drained the Ahuriri Lagoon, exposing a seafloor that became instant farmland. The earthquake also dropped other areas below sea level, creating new lagoons where farms had been. This instant geography lesson showed how quickly Earth can redesign its surface. Salt took years to leach from the newly exposed land before crops would grow. The old lagoon bed is still visible from the air, its outline marked by different soil and vegetation. Drainage channels cut across what was once the lagoon floor, their patterns revealing the submarine topography. Buildings now stand where fish swam, roads cross where boats sailed. The airport runway follows the former lagoon edge, built on land that didn't exist before that February morning. This transformed landscape serves as a reminder that what seems permanent can change in seconds, that today's seabed might be tomorrow's farmland. Pupu Springs releases 14,000 liters of crystal clear water per second, creating a river from nowhere in the middle of a valley. This water has traveled underground for years, filtered through marble aquifers until it achieves clarity exceeding 60 meters visibility. The springs maintain a constant temperature year-round, immune to seasons, their flow varying only slightly with rainfall patterns from years before. The water emerges through vents in white sand, creating underwater fountains that push sand into dancing patterns. Scientists have traced the water's origin to the mountains, following underground rivers through cave systems no human has seen. The water is so clear that photographers struggle to show it's there. Objects underwater appear to float in air. Swimming is now prohibited to protect this clarity, as even clean human skin introduces oils that cloud the water. The springs are considered sacred by Maori, a place where underground and surface worlds meet. Dancing sand in the vents creates patterns that never repeat, eternal motion powered by Earth's hidden waters. This is water as pure as nature can make it, a standard against which all other waters are measured. The Kaipara Harbor spreads across 947 square kilometers at high tide, the largest harbor in the southern hemisphere, yet few New Zealanders have heard of it. At low tide, 500 square kilometers of mudflats emerge, exposing a landscape that exists only half the time. The harbor has claimed more ships than any other New Zealand port, its entrance a maze of shifting sandbanks and powerful currents. Tidal flows through the entrance reach speeds that challenge modern motors, creating standing waves and whirlpools. The harbor formed when rising seas flooded a vast river system, creating a branching network of waterways extending 90 kilometers inland. Mangroves grow throughout the harbor, their global southern limit, creating underwater forests that appear and disappear with tides. Millions of migratory birds use the harbor, timing arrivals to lunar cycles that govern tides. From the air, the harbor resembles a giant tree. Its trunk, the entrance, branches the various arms reaching inland. This twice-daily transformation from water to land and back creates one of Earth's most dynamic landscapes, constantly changing yet eternally the same. Mount Tarawera's 1886 eruption tore a 17-kilometer chasm across the landscape, up to 250 meters deep in places. This rift, created in just 4 hours, remains raw and unvegetated in sections, as if the eruption happened yesterday rather than over a century ago. Steam still rises from vents along the chasm floor, and the rock remains warm to touch in places. The eruption created a new geography, lakes where none existed, hills split in half, rivers finding new courses. Walking along the rift edge feels like walking on a wound that won't heal, the earth still broken from that night of violence. The chasm reveals the mountain's internal structure, layers of different eruptions visible in cross-section like a volcanic textbook. Rain has carved gullies in the loose material, creating badlands topography that changes with each storm. Some sections have revegetated, pioneer plants beginning the centuries-long process of healing, while other areas remain bare, too unstable or toxic for life. The chasm serves as a timeline. The longer since the eruption, the more vegetation, creating a gradient from bare rock to forest. The Southern Alps grow 7 millimeters taller each year from tectonic compression, yet simultaneously erode 10 millimeters from rainfall and ice. This means the mountains are slowly shrinking despite the enormous forces pushing them skyward. The math is relentless. For every meter the mountains rise, they lose 1.5 meters to erosion. Rivers run gray with rock flour, carrying the mountains grain by grain to the sea. The West Coast beaches are built from the Southern Alps, sand that was once mountain peaks. This battle between uplift and erosion creates a landscape in constant flux. Today's summit will be tomorrow's valley sediment. Earthquakes occasionally upset this balance, lifting sections meters in seconds, temporarily winning against erosion. The mountain's shape reflects this struggle: sharp peaks where uplift wins, rounded hills where erosion dominates. Glaciers accelerate the erosion, grinding valleys deeper, carrying millions of tons of rock toward the sea. This mountain range is middle-aged in geological terms, high enough to impress but slowly losing the battle against gravity and rain. In a few million years, they'll be hills, their substance spread across ocean floors, waiting for the next tectonic collision to lift them again. And so, our journey through New Zealand's geographical wonders comes to rest. We've traveled from the depths of ancient fjords to peaks still rising from tectonic forces, from hidden caves where glowworms create false skies to beaches where the sand burns too hot for bare feet. These islands at the edge of the Pacific continue their slow dance, rising here, subsiding there, shaped by forces both violent and gentle, patient and sudden. The landscapes we've explored tonight will be different tomorrow, changed in ways too small for human eyes to notice, but too numerous to count. Rivers will carry a few more grains of mountain to the sea. Glaciers will retreat another hand's width. Somewhere, a wave will finally topple a sea stack that stood for millennia. And somewhere else, volcanic heat will create a new hot spring, opening a window into Earth's restless interior. As you drift toward sleep, perhaps you'll dream of turquoise lakes colored by glacial flour, of forests growing sideways in endless wind, of rivers that flow uphill and mountains that make their own weather. Perhaps you'll imagine standing at Cape Reinga, where two oceans meet, or descending into the blue twilight of Cathedral Caves, or watching the sun first touch Mount Hikurangi, while the rest of the world remains in darkness. These islands continue their ancient stories, stories written in stone and water, in ice and fire, in the patient work of wind and rain. Tomorrow, the Taieri River will continue its meandering journey, taking 3 times as long as necessary to reach the sea. The cushion plants on the Ruahin Range will add another microscopic ring of growth. And beneath Aotearoa, magma will continue its slow circulation, preparing for eruptions our species may never witness. Thank you for joining me in discovering the quiet wonders of Aotearoa, where Earth reveals both its violence and its patience, its power and its fragility. Until next time, this is Midnight Geography, wishing you peaceful dreams of distant islands and ancient mountains. Sleep well.